Hello everybody, I will start my today's another coding practice. So today I will solve this question, longest palindrome substring. So in this question, I will be given a string s and I will return the boolean if, I will return the longest palindrome substring in the given string s. I will return the string. Okay, so today for this question, I will introduce three solutions, three approaches. The first approach is using the 2 pointers. And the second approach is top-down dynamic programming. Sorry. And the third approach is bottom-up dynamic programming. Okay. So that being said, let me get started. So for before diving into 3D solutions, I will quickly tell you about the brute force approach for this question. So the brute force approach is that I will think of every possible substring, and I will check if it is palindrome or not. Then I will return the longest one out of all the substrings. Yeah. So that's the brute force approach, obviously, but this takes O and cubed. This is because I will think of every substring, and number of the substring is, every combination of left edge index and right edge index. So it should be n squared. And for each substring, I have to check if it is palindrome or not. So I have to traverse the string, maybe using the 2 pointers. So it should take O of n for each substring. So multiplying them, I will get O of n cubed. Okay, so that's the brute force approach. So that being said, let me introduce the first approach, 2 pointers. So in the 2 pointers approach, let me tell you with some example. For example, in this case, I will take the center first. Yeah, center character. Then, firstly, I can definitely say when I choose one character, it is already substring. No, palindrome, because this is a single character. And then I use the 2 pointers. And right pointer goes rightward, left pointer goes leftward. And every time, left pointer and right pointer moves in the same speed. So, firstly, left pointer goes by 1, right pointer goes by 1, and I will check these two string characters. So in this case, I compare A and A because they're the same. I can say I could expand the palindrome range. So now I can say ABA is also the seventh palindrome. However, when I expand one more, left pointer is now B and right pointer is now D. And because B is not D, I can say this is not palindrome anymore. So in that way, I choose the center character and they expand the scope, range, until it's still the palindrome. So in that way, for each center, I will think which substring is the longest palindrome. And one more thing I have to take care is that in this case, I said the center character is single character, but it is also possible that when I choose the center first, I choose B and B, or I should say, I put the center between two characters. This is also possible. So in the case of ABBA, when I pick the center between two B's, then I start the traversal, 2 pointers from this B and B. And then I can say, now left is equal to right. So now my palindrome substring is palindrome, whose length is 2. And from that, I move left pointer and also right pointer by 1. Then again, a is equal to a. So now my palindrome is expanded. But however, I cannot expand it anymore because left and right are on the edge. Okay, so in this way, I can say if I take the center between two characters, the palindrome I will be thinking is even. I mean, number of the characters is even always. But when I take the center, a single character, then the substring I will be thinking would be odd lengths. Yeah, so that being said, for each left, I will move left pointer and right pointer. And for each left, right pointer should be exactly left or left plus 1. These two are, centers with fixed L. And for each L, I can choose the initial left right in the same way. And then for each, I will do the, the pointers expanding from center. Okay, so let me start the implementation with this. Yeah, so now I've written something. So I choose each left, and for each, their right center can be left to left plus 1. And I do the check here. So even for the first position, I will check if this is palindrome or not. Especially for right is left plus 1 case. Because if left is equal to right, I can always say it's a palindrome. Yep. And what I will return is the longest palindrome. So let me initiate longest range in this way. Because the given string has at least one character and also single. So if I take the first character only, it's always a palindrome. So that's what I can say. And so for now, I will put this, assume this as the longest range, and update it when I find the one which is longer than this range. Okay. So here, current longest one is this. And the current length is this. If current length is longer, then I will update longest range in this way. Yeah, that's it. Then also I have to move the pointers. Okay. Then in the end, I will return the substring in the longest range. Okay, so this is it. Yeah. One thing I'd like to tell you is that I always keep track of the longest range, not the longest substring. It's because if I try to keep track of the longest substring, which means that every time I reach line 36, I have to eat the longest palindrome candidate string. So in Python, when I try to make the new string from the original string with slicing, it will take O of n according to the length of the substring. So I don't want to repeat that. So that's why I keep track of the longest range, which is the table. Okay. So that being said, let me use my code. Okay. So one thing I have to take care is, let's take a look at left, which is initiated in line 28. This left is updated in line 38. So this means that when the inner loop step is finished and come back to, it goes to another step in the inner loop, the left is not something which is set in line 28. That's the problem. So let me say like this. Yeah, so this is what I have to take care. Oh, okay, now it's accepted. Great. So this is a 2 pointers approach, and the time complexity of this should be n squared, because I will take the center, which can be 2n, yeah, variations. So yeah, obviously when left is equal to right, I will have n choices, and when right is left plus 1, there are also n plus 1 choices of the start, and then for each, I will do 2 pointers for expanding the scope. And in the worst case, I have to, 2 pointers traverses exactly the ranks of the given string S in the worst case, which is n. So 2n by n, which is n squared time complexity. And for space complexity, it should be O1. I don't use any non-constant data structure. In line 47, I initiate another string, substring, from the given string, but this is the returned string. So for the extra space complexity, it should be O of 1. Okay. Now let me work on the second approach, which is top-down DP. Okay, for the second approach, I will use top-down DP. So let me tell you why I can use the top-down DP here, especially dynamic programming here in this question. So if, let me say, I'd like to answer, say, some string like this is substring or not. Sorry, palindrome or not. To answer this question, I have to take a look at two things. The first thing is I will take a look at leftmost character and rightmost character and check if they are the same. And if they are the same, and also the inner string is the palindrome, then I can say this string is palindrome. So obviously, this I can, yeah, I answer the question if BAAB is substring and palindrome or not with the subs problem, which is AA inner string is palindrome or not. And also, leftmost and the rightmost chairs are the same or not. So I can solve this question in that way, in a recursive way. And also, I can, memorize the answer of the question if AA is palindrome or not once it is answered. So if I say BAAB is the palindrome, then it's always true. That answer doesn't change. So I have to keep track, memorize it. So I can say I can use the recursion with memorization. So I can say I can use the recursion. Okay. So, yeah. And for the base case for this recursion, if the, I mean, length of the string is 1, I can always say it is the palindrome. I can return true and it's the end. And if the characters are only 2, like AA or AB, if they're the same, it's palindrome. If not, it's not palindrome. So that's a base case. Otherwise, as I said, I use the recursion. So what I mean to say is, if I'm given the substring or substring range, I can answer this question with dynamic programming. So I have to take a look at each substring and then there are n squared, substrings. So I will, answer that for each. I mean, I will answer the question if it is palindrome or not for each substring, and then I, out of palindrome substrings, I will return the longest one. Okay, so let me work on the implementation. So this is the recursive function I will implement. Then for each range, I will take a look if it is palindrome or not. And if it is palindrome, I will keep that range if it is the longest. So basically, for the tracking range, longest range, I can use the same way as the solution one, the pointers approach. This should, yep. Okay, then just like before, I return the longest one. Yep. So the good thing about this approach is that in line 66, I check if it is palindrome or not for each substring. So this seems like the same as the brute force approach. However, because I cache the answer left to right, so I don't have to, check if some substring is palindrome or not again and again. I can, avoid duplicated checks with the memorization. Yeah. So now I will implement the is palindrome method. This is the first base case. And this is a second base case. And this is the recurse. Otherwise, I will use the recursion. Like this. Okay. Good. So for this recursive function, aside from the another recursion code, all of the operations are constant time. And its palindrome method is called in total n squared time because n squared times because I will check for every combination of left and right. This should be n squared. So actually, with the memorization, this takes only n squared time. Yeah. I mean, so this recursive function is called n squared times only, and for each, aside from this one, all of them constant. So I can say the time complexity is n squared. And for space complexity, it should be over n squared for the cache memorization. Yeah. Except for the return string. Okay. So memo for cache. The key, I mean, key is left-right combination. So they're n squared key value pairs. And for value, it is Boolean. So it just takes a constant space. It should be n of n squared. Okay. Now I'll submit my second solution. Good. Yeah. Unfortunately, I checked this solution before this video, taking this video, and I found that this solution experiences memory limit exceeded. There are so many people asking about this in the discussion forum, but yeah, unfortunately, yeah, memory limit exceeded this solution. Yeah, but if I use the bottom-up dynamic programming approach, it accepted, even though the space complexity would be n squared. So let me introduce that. Okay, so for the third approach, I will use the bottom-up DP. So I will use, instead of the recursion with memorization, I use the DP table. In this case, it should be 2D DP table, 2D table. So say if I'm given string like this, the DP table should look like this. So the vertical character, each character in the vertical line, each suggests that the substring I'm thinking begins from that string. So for example, for here, the substring, which is represented by this position, is A. And for example, if I take a look at this, oh, sorry, this, this position, it begins with B and ends with A. So this position signifies BA. Yeah, that's that. So if I say that, obviously, I don't have to think of these cells because, for example, this, it should start from B and ends with A. So it's going reversely. So I don't have to think of these positions. Yeah. So that being said, let me take a look. So if I take a look at this suggests, this signifies substring A, which is obviously substring, no, palindrome, because it's a single character substring. I can say all these positions are a single character and they're, palindrome. And for this here, they are two character substring. So I can check if for each substring, I will check if two characters are the same. And if they're the same, that is a palindrome. Otherwise, it isn't a palindrome. That's how I can find out if this is palindrome or not. And for this position, from here, it becomes a bit interesting. So this is the string which begins from A and ends with B. In this case, this is ABB. So how can I know if this is palindrome? So for that, as I said before, I will first check if the start char and end char is the same. And if they is the same, and also the inner string is substring, palindrome, sorry. ABB is also palindrome. So I will use that. So for here, firstly I will check if A is equal to B. In this case it isn't, so this is false. And for here, not true, okay. But here, B is equal to B. So the first condition is met. So I will take a look at the inner string. So where is the inner string represented in this table? So it starts with B and ends with B here. So the inner string is, it starts with A, one character later, and it begins with A, which is one character before, and B. It should be here. Yeah. So when I try to note this, and if I already know this, I can say if this string is palindrome not can be found out from this equation. Yep. So this is how I fill in the DB table from the subprogram answer. Yeah. And if I try to do this, the order of filling in the DB table matters. So obviously, because I have to know the right bottom directions cells answer, so I will fill in the cell in this order: 1 layer, 2 layer, 3 layer, 4 layer, 5 layer. Yep. So in that way, I can always fill in the DB table cell in constant time. Okay, so that's the main idea. So the time complexity should be O of n squared. As I said, I have to fill in n squared divided by 2 cells, and for each, it takes only the constant time. So the time complexity should be O of n squared. And for space complexity, obviously I need the DB table, 2D, so it should be n squared. Okay, so let me get started with the implementation. So this is how we initiate a DB table. And firstly, I would go from here and then go from here, go from here. So I use the for loop for firstly for deciding the first step in each layer, like this. And for start index, it should be always 0. Yep. And for each, I will check this is not for each start end. So I will start from this and wait a minute. So this is the end index and this is the start. I see. So if this is met, the start and cell is inside of the table. From now, I fill in the table. I'm doing something which I did in my previous approaches here. So I firstly check this. Yes. So this is how I fill in the DB cell. And if it was filled with true, then I will update the longest range. This is completely the same as what I did before. Like this. Then in the end, I return the longest substring, just like I did before. Okay. Looks good. Let me execute my code. So this isn't true. Oh. Let me quickly check. Oh, what I forgot to do is I have to, update start index and also end index. And also here, it should be end minus. Oh. This should be okay. Now it's accepted. I will submit my code. Great, it accepted. Okay, so let me wrap up my today's practice. So in this video, I solved the question longest palindromic substring. And I'm given string S and I return the longest palindrome substring in this question. And for that, I used 3 approaches, each of which takes O and a square time complexity. The first approach is 2 pointers. Yeah, so in this approach, I choose the center position. There are 2 n center positions possible, and I will try to expand the left pointer and right pointer, and until the left-right range is palindrome. And every time I find the longer substring, I update the longest palindrome range. Yeah. And then I return the longest ranges substring. That's my first approach. And the second approach is top-down dynamic programming. So basically, I use the ideas that if I try to find if string is palindrome or not, I take a look at the leftmost and rightmost characters, and if they're the same, and also in a string is palindrome, then the given string is palindrome. So obviously, I use from the subproblem's result, I can answer the current problem's result, and also I can use the memorization for the result of the question if each, specific range is palindrome or not. So that's why I can use the top-down DP. And the third approach is bottom-up DP. So I created the 2D DP table, and I fill in these table cells. Yeah, each of which takes constant time. And the order to fill in the cells in this DP table mattered in this question. So, yep, that's what I had to take care in. Okay, and that being said, I think top-down DP approach is the most easy to implement. Or maybe, no, sorry, 2 pointers approach is obviously this is the most simple and easy to implement for me. So I prefer this one. And I think this is the most challenging, Bottom DP one is the most challenging thing. Okay, so that being said, I finished my today's coding practice. Thank you so much. Bye.